Thank you, James. I just recorded it now. So all we're doing is just expanding that 2 into the coefficients in front of the log. And then we are taking the power law and just applying it to these guys over here. So what we're essentially doing is we're going from the right side to the left side in this example. So we're left with log 4 of b2 to the power of 6 minus log base 4 of b3 to the 2 and log of 4 of b to the power of 4. So all we need to do next is multiply our exponents. So we're left with log base 4 of b to the 12 minus log base 4 of b to the 6 plus log base 4 of b to the power of 4. So using the laws from above, how can we simplify this expression now? So we're going to add and subtract. So the first one we have subtraction. So we're going to divide the logs together. So we get log base 4 of b to the 12 over b to the 6 plus log of base 4 of b to the 4. So what is 12 minus 6? So 6. So we got log of 4 b to the 6 plus log of 4 b to the 4. So our last step is simply just going to be to add these guys together. And we're left with log base 4 of b to the power of 10. Yeah, so we can start with division first, which is what we did. So b12 over b6. And then the last one was multiplication, so we added the exponents together. So example 2, we want to write each expression in the form of r times log of b x. So when we expand that 2 in, we need to change it we need to use the power rule. So we need to change it from r log of b of base b to the x in the form of log base b x to the r. That's what we would have to change it to. So in this one, we're going to be using the power law. So we have log of base 2 of 6 to the negative 1. So if we were to change it to the form of r log b to the x, what would our logarithm look like? So all we're doing here is bringing the exponent as our coefficient. So this one would be negative 1 log 2, 6. And then the next one we have is log of base 3 of the quintic root of 45. So what we need to do first is simplify the roots. So what would our single logarithm expression look like? So again, all we're going to do is bring the exponent to the front. So we get 1 over 5 log base 3, 45. Yep, thank you, Joseph. Thank you, Matthew. Now we're going to move on to the last few examples, and then you guys are free to go. So we want to simplify using the laws of the logarithms, if possible, and then evaluate. So the first one we have is log base 6 of 1 over 4 plus log base 6 of 4. So how would we be able to simplify this? So we're going to multiply 1 over 4 and 4. And we get log of base 6 times 1, which means if we were to evaluate this, what would this whole expression give us? Zero. So this whole expression gives us 0. So log 6 of 1 over 4 plus log 6, 4 is all equal to 0. The next example we have is log base 8, 48. Plus 2 log base 8, 2 minus log base 8, 3. So what is the first step that we need to do to solve this expression? So we're going to use the power rule. So we got log base 8, 48 plus log base 8, 2 to the 2 minus log base 8 to the 3. And we know 2 to the power of 2 is just going to be 4. So we get log base 8, 4 minus log base 8, 3. So what would our next step be? So you're going to multiply and then divide. Or you can do everything at the same time. So we get log base 8 of 48 times 4 divided by 3. And what does that expression give us? What is 48 times 4 divided by 3? What does that give us? So it gives us 64. So what would this expression give us? So the answer is we need to figure out a to the x is equal to 64. So what exponent with a base of 8 gives us 64? 2. So this is all equal to 2. So is everybody more comfortable with this now? Perfect. Okay, so example C, we have 2 to the power of log base 3, 9, plus 2, plus log to the base 2 of 4. So because they don't have the same bases, we need to evaluate each one individually. So for the first one, we have log base 3 to the power to the 9, which means 3 to the power of x needs to give us 9. So what value of x would that be? 2. So our first exponent is 2. And then the next one we have log base 2 of 4, which means 2 to the power of x needs to give us 4. And what value of x would that be? 2 again. So we have 2 to the power of 2 plus 2, which is equal to 2 to the power of 4, which gives us an answer of 16. And then our last example we have is 1 over 2 log base 5 of 250 minus log base 5 root 2. So what we're going to do is use the power rule again. So we got log of 5. This turns into 250 to the power of 1 over 2 minus log base 5 root 2, which is equal to log of base 5 or root 250 minus log base 5 root 2. What would our next step be? we're going to divide. So we get log base 5 of root 250 over root 2. And when we simplify, that gives us log of base 5 of root 125. And now we need to figure out 5 to the x is equal to 125. So what value of x gives us a solution of 125? So 3. So we get log 5 of root 5 to the 3. And then all we have to do is simplify that. So we get log of 5 to the 3 times 1/2, which means this expression is equal to what value? Nope. So we have 5 to the 3 and 1/2. When we have an exponent to an exponent, we have to multiply the exponents together. So this expression just gives us a value of 3 over 2. Okay, we have our example 4, and we have 3 more examples. So we want to write log base a of root x times y to the 5 in terms of log base a x and log base a y. So all we have to do is split up both of them. So we have log of a times root x times y to the 5. And then we can write each of these as separate logarithms. But remember, because they're being multiplied, we need to put the addition sign in the middle of both of them. So this equals to log of 5 of x to the 1/2 plus log of a y to the 5. And then we have to use our power rule. So we're just bringing the exponents forward. So we get 1 over 2 log base 5x plus 5 log base a y. So is everyone good with the last few examples that we just did? All right, perfect. So you have 2 more examples and we will call it a day. So example 5, we want to solve for x. So we have log base 2x is equal to 2 log base 2 3 plus log base 2 7. So we need to use the oh, I meant to write log A. That was my mistake. So for the last example, they should all be log base A. I wrote a 5 by accident. So the next one we have to use our quotient or product law because we have addition. So we need to bring this 2 as our exponent for the 3. So we have log base 2x is equal to log base 2, and 3 to the power of 2 gives us 9, plus log base 2, 7, which means we get log base 2x plus log base 2 of 9 times 7. And because the logs are of the same base, we can ignore them. So what does our x value give us? $63. So which means x is equal to 63. And last but not least, we have log of x plus log 4 is equal to 5 log 2. So again, we're just using the product law. First, we have log of x plus log of 4 is equal to log of 2 to the 5, which is 32. And now we just have to use our product law. So you get log of 4 times x is equal to log of 32. The logs can cancel each other out because they have the same base of 10. So we are left with 4x is equal to 32. And what would x give us? 8. So x is equal to 8. So the 32 we got from the quotients or the power law. So remember the 5, when we bring it back, it becomes 2 to the power of 5. And then we have our last example. We want to describe the transformations that take the graph of f of x log 3x to the graph of g of x is equal to log base 3 of 27x cubed. So we can't just automatically say right away that it is a horizontal compression of 1 over 27 because that is not true. We need to use the different laws that we use today. So for this one, we are going to use the product law. So we have g of x is equal to log 3. And now we need to write 27x cubed as a product of two separate values. So because the base is 3, we need to write 27 as 3 to the power of a exponent. And because we've done it so many times, we know 3 to the 3 gives us 27, and we can times that by x to the power of 3. Which means this gives us log of base 3 of 3x to the power of 3. And now here we have to use our power law. So when we use the power law, what happens to that exponent of 3? Where does it go? It goes in front of a log. So we get g of x is equal to 3 log of base 3 of 3 to the of 3x. So now looking at this, what types of transformations do we have? What's the first transformation? So you have a vertical stretch by a factor of 3. And what is our last transformation? You have a horizontal compression of 1 over 3. So again, we just manipulated that last example by using the different rules or laws of logarithms so that we can simplify it more. So what you guys can do